Let's hit some reload and see what happens here. Hopefully we're connected now. Alright, we're live. Exciting stuff. So, sorry I'm a little bit late. Twitch, for some reason, invalidated my stream key again. This is the second time they've done that. And now they've moved the stream key setting so that it's 3 pages down, and I didn't see it, and I spent 10 minutes trying to figure out how to get my stream key. But we're online now. Let me go ahead and tell Twitter. Alright, streaming game dev, gonna do some voxel prototyping today. Come see if you want to relax. Paste. Alright, so after all of that time, I gotta close about 10 tabs of trying to figure out where Twitch stored its keys, and we are ready to rumble. Okay, so Recton France says hello and waves. Hello. Today I'm going to be doing some prototyping rather than working on the galactic line, and that's because I've gotten some really good algorithms and UI elements running, and so I can't just let them die. So we're going to go ahead and build a little prototype out of them and see how they perform. This is a long weekend coming up, so if this turns out to be pretty good, I can spend, you know, 30 or 40 hours this weekend getting it to be playable. This is a brand new project, so if you are wondering how people create prototypes in Unity from scratch, well, guess what? You're about to find out. We're going to be working on a voxel project today. That will be a good place for us to really give our new physics system and some UI polish and some backend stuff a good workout. Right now I'm just trying to create something that's a little bit ground-like so that we have something as a drop so that we can get to work and not have to worry too much about it. So there's our ground. And what we're going to do now is create a cube. And that's going to be at 0, 0, 0. Why do you name this quad ground? We'll name this cube chunk. And what we're going to try and do here is create a very simple voxel system that has cool physics. And to do that, we're going to need to be able to walk around this voxel world and click on stuff. Alternately, we could try and do it using an alternate, interface here in the inspector. But with voxels, it's probably best to be able to walk around. It's a tough call, but we're not at the stage where we're ready to do that either direction. So for now, we're just going to start to lay the groundwork for our voxels. And that means we're going to need some scripts. We're going to do all this in C#. So let's go ahead and create a voxel chunk script. This will be the thing that we're going to build off of to get all of our functionality. There we go. Public int width equals, doesn't really matter, 64. And public int height equals 64. None of that stuff it's all temporary at this stage. Obviously, it's just a prototype. But that will be our voxel scope. And then we're going to have a public byte map. And that map is going to be the width and the height. We're not going to be working with any sort of terrain generation. All of this stuff is going to be clicked into existence, so we don't have to worry about filling out that with whatever voxels happen to be on the ground in the area. We can just start from scratch. We're going to have to map this to a new... Oh, I put that in the wrong spot. Brilliant. We're going to have to map this to a new set of... a new palette. We're going to have to at some point understand what 0, 1, and 2 stand for in the map. but for now we're just going to leave it as that. But what we can do is set this up as having a specific set of rules for us to interface with it. And for that purpose, we are going to go ahead and, well, I guess we're just going to go ahead and bite the bullet, start to do this. Recton says, wow, that's cool. Glad you think so. I run a very, very boring channel. It's just full of programming. So if you're happy to see programming, then you are in the right place. Normally I work on the galactic line, but this idea is a little too frantic. I can't work on something else while it's in my head. So we're going to have this set up this as the width times height. And that's going to be our array of voxels. This isn't necessarily the best way to do it for a sparse voxel situation, but it's going to be good enough for our purposes. So when we actually go over here and we take a look at the voxels, you can see that our map is empty, but as soon as I hit play, it fills up with 4,000 entries, and that's exactly what we would like. Then what we can do is change those entries and recalculate. So let's go ahead and put in a public void calculate voxels. I should say calculate mesh, shouldn't I? Mesh. I've got to reorient my Twitch screen. I can't see the right-hand side. Recton says, I love programming right now. I'm on a project for a server of an old MMORPG. That's always fun. The real problem I have with this particular idea is that it's going to have to be multiplayer, and that means that I'm going to have to do some server stuff, and it's not my favorite. Good news is there's a lot of Unity middleware that can do it for me, so that'll be nice. So we're going to make calculate mesh something which can be called from the menu, like so. And we're going to go ahead and let this specify a mesh for us to calculate. And that way we'll be able to do this relatively straightforwardly. So what we're going to be doing is creating a mesh that contains the various showing faces of our byte map. There are a lot of ways to do this. We're just going to use a very, very basic approach. And that would be we're going to go through and create all of the tries that we're going to need. There's no reason for us to work out anything here except for what we're going to need at the end. We're not going to like load up the mesh or anything like that. We're just going to do a raw, pure force calculation. Now, there are a couple of ways to do that. The easiest way is to use a list. So we'll go ahead and start with that. Later on, when we need to fix this, or rather polish this, we can do a pass to get rid of this list and have a correct length array in there from the start. But for now, it's not too bad. And then we're going to also need the tries. And this will be all we need to get our voxel chunk built. Except for I just realized that our voxel chunk only has a width and a height and not a depth. So we're going to go ahead and add in depth, because this is a three-dimensional voxel structure. There we are. So what we're going to do is we're going to go through all of the map and just build the stuff we need to do. So for int x equals 0, x is less than, actually we start with z, don't we? Int z equals 0, z is less than depth, z++. For int y equals 0, y is less than height, y++. See if we can do this while spelling it right. That would be a big help. And for int x equals 0, x is less than height, or width, x++. Yes, that's what I wanted, bone weight. Not width, a local variable, but bone weight. All right, so now that we're in here, what we're going to want to do is get the correct index from the map. And there are a lot of ways to do this, but by far the easiest way to do it in terms of saving on math is just to understand that these are always going to be a flat increment. So we're going to go ahead and just say index plus plus at the end. So flat increment the index instead of spending time multiplying it out. I don't normally go for optimization this early, but that one is really very basic, and it's much, much simpler than saying, you know, index equals x plus y times height plus z times height times depth. We'll do it this way, much, much more straightforward. So we've got a byte value at a specific map coordinate. So what we're going to do is we're going to build we're going to build this. So switch map index. And what we're going to do is default debug.log unknown material and then the map index. Continue. Rather not continue. Yeah, continue, that's fine. Is it break? It's break. Continue would go to the next if for thing. Otherwise, we're going to say case 0, empty space. Case 1 is also empty space. The reason that case 1 is empty space is because we're going to be using an object array for things like chairs and pots and doors, and we're going to put a 1 in there if it is an object. So from our perspective, 0 and 1 are both empty space, which means that case 2 is our first real material. So we're going to go ahead and create a new voxel system or voxel element for this. It would be best if these were outside of the array. Otherwise, we're going to have to pass them around a lot, and that's going to be annoying. So let's not do that. So here we'll say verts.clear and tries.clear. Right, that initializes those. And then from here, we can say create voxel and then pass it in the X, Y, Z, and material. So it's map, or I guess just map 2 is fine. The reason I'm saying map index rather than 2 is because I can make this much more diverse later on. There we are. That is our voxel creation algorithm. So public void create voxel, byte material, int x, int y, and int z. So when we're creating the voxel, we're going to want to go ahead and come up with the verts we're going to need. And that means we're just going to be adding in the 8 points of the cube. Later on, we can do some face culling, but for now, we're not going to do any face culling. So that means that we're going to have faces even where you normally wouldn't be able to see them. It's lossy. You don't want to do that, but for now, it should be fine. So vector3 base, or corner equals new vector3 x, y, z. And then we'll say verts.add corner, verts.add corner plus vector3.right, verts.add corner plus vector3.right plus vector3.up, because we are doing x, y, z, I believe. And then verts.add corner.vector3.up. So that is one of our faces. And you can see that what we did is we went along in a counterclockwise fashion, or a clockwise fashion, depending on which direction you're looking, I suppose. And that's going to be helpful when we are doing our tries, because our tries specify which of these points are going to be connected by a face that the outside world can see. We're just going to duplicate this and add in a vector3.forward for the next set of corners. Now, we do have a bunch of different options here. This is the most efficient option in terms of keeping the number of vertices low, and that's because it only has 8. If you wanted to use sharp-edged elements, then you would need to use 4 verts for each face, which would be 6 faces times 4, that would be 24 verts, which would be substantially more verts. But that would produce a crisp-edged element rather than what we've got here, which would be a rounded-edged element. So we're going to go ahead and not do this, and instead we're going to make it so that we have all 8 faces. So for that, we're going to have a function where we create a face. Public void create voxel face, and that would be int, or rather vector3 corner, vector3 right, vector3 up. So what we're going to do is take this and move it down here, and then we're just going to replace these with the values that we've added in, like so. And we're going to create two tries with this information. So tries.add, we need to have the index, so int index equals verts.count. And then we can say tries.add index. Can we put a corner here? Or a comma here? No, we can't. Okay, that's fine. Then we do index +1, index +2, and then we do the other try, which is the other side of this equation. So if we're doing 1, 2, 3, then the other one is 3. Sorry, if we're doing 0, 1, 2, the other one is 2, 3, 0. 2, 3, and 0. Perfect. So up here, what we're going to do is we're only going to create one face for the moment, just so that we can see whether or not this is working. So create voxel face, corner, and then pass it in vector3.right and vector3.up. Later on, we'll create the other faces. So when we get through, we're going to have gone through all of these elements looking for voxels, and if we find some voxels, we are going to put a face into the game world. But we haven't actually assigned any of these to the mesh. So mesh equals new mesh. Let me say mesh dot verts equals verts dot toArray. Mesh dot tries equals tries dot toArray. Mesh dot recalculate normals. Mesh dot recalculate bounds. There we go. And then what we're going to do is make that mesh part of our mesh filter. Now the problem is, so mesh filter dot mesh equals mesh. The problem is that that's going to bleed in inspector mode. So if we're not in play mode, we're going to end up bleeding meshes. But nobody cares if we're already in play mode, and we have to be in play mode for this to work. So whatever, right? Right now, let's go ahead and take a look at the map. We've got... Oh, it's huge. Sorry, I got to... Let's go ahead and bring this down a notch. I do not need 131,000 entries into an array I'm trying to manually edit. That sounds obnoxious. Hopefully it will stop at some point here. Oh, it is stopped. I was just being dumb. So this should go away now? Yeah. Let's go ahead and change this to an 8 by 8 by 8. That's more manageable. There we are. So if we were to do this, then we can put in some 2s and see what happens. So now we're just going to tell it to calculate the mesh. And it says variable, I forgot to assign the mesh filter. You've got to plug things in order for it to work. I've said that a couple thousand times by now. Oh, I pressed save. My bad. Let's go ahead and save it. Garden. There we are. And drag this down here. Hit save again, and then hit play. The reason I'm hitting save so religiously is because there's a high likelihood of accidentally creating an infinite loop when you're not sure what's going on, and I'd rather not have that happen. So, you know. Calculate mesh. Well, we definitely got rid of the old mesh. Oh, look at that. We've got our faces lined up. Pretty as can be. Notice that they're only visible from one side, and that is the core problem that a lot of beginners have when making their own meshes. Triangles only render from one direction. But this happens to be one of the directions. I'm not actually sure whether it's the right direction or the wrong direction. We can find that out now. So what we're going to do is we are going to start to add in two faces. The other face is going to be plus vector3.forward. This face is going to have the right and the up. These are, we can specify them as right and up if we would like, but that's going to create a face that's facing the exact same way as the other face. and we need it to be the opposite. So what we're actually going to do is add in a vector3.right here, and then pass it the negative vector3.right. And that should allow us to get a face that's facing the opposite direction. The only question is whether or not it's currently facing the correct direction or backwards. And we will know that right now. Oh, it's backwards. So that's no big deal if it's backwards. It just means that you have your tries in the wrong order. And you can just rearrange them like so. And hit play. You know, I've been doing this forever, and I still can't ever get the order of the faces to work out on the first try. It's not a big deal as long as you get a hold of it before you get any further. And there you can see we've got faces this way and faces this way. Let's go ahead and finish off all of the directions that we can face. So that is the front and back faces. We're going to want to create the right and left faces. So corner, comma, and then we're going to do vector3.forward and vector3.up. And then we're going to want to have the same thing we did here, except for instead of vector3.right, it's going to be vector3.forward. And now the question is this forwards or backwards? Let's find out. Oh. Oh, great voxel face. My bad. So if we take a look at the chunk, let's go ahead and put in some values and then calculate it. And if we take a look, you can see that these are not correct. Idiot. Not only is the face in the wrong direction, I also moved it forward instead of to the right. Alright, so this should be right. And this should be... okay, so this should be plus vector3.right. And this one should be plus vector3.forward. And that should create the left and right faces, I think. Let's go ahead and give it a shot here. Calculate mesh. Perfect. So you can see that all of the internal faces are still being created. We're going to go ahead and get rid of those in a minute here. In fact, it might be best to get rid of them now while we can see what we're doing, closing off the last two faces. Well, let's go ahead and close them off, and then we'll comment it out, just so that we are, you know, on track. So now what we need to do is create a voxel face out of the forward and right, rather than out of the up and right or up and forward. And then here, we're going to do the same thing, but up. I don't know which of these is going to be correct, though. So we're going to have to just try it and see. Plus vector3.forward minus vector3.forward. Pause, and it looks like I got it right on the first try. Hurrah! So now we have all of the faces getting created. Let's go ahead and optimize out the faces that we don't need to create, just because that will allow us to save a little bit on faces. So what we're going to do is we're going to have a new value called Cole's faces, and pass it in an X and a Y and a Z. This will allow us to return whether or not the block in question is opaque. So it shouldn't be called Cole's faces. It should be called is opaque. Let's call it that. Cole's faces is what we're using it for, but is opaque is a lot more easy to deal with. So we're going to go ahead and just check and see a couple of edge cases. If x is less than 0 or y is less than 0, or z is less than 0, or x is greater than or equal to width, or y is greater than or equal to height, or z is greater than or equal to depth, then we'll want to return false. Off chunk, don't cull. Otherwise, we'll want to just check and see what sort of face we're looking at. So switch, so int index equals x plus y times width plus z times width times height. And then we say switch map index. Default, return false. Case 2, return true. There we are. Perfect. So what we're going to need to do is just do a quick check on isOpaque for all of these values. We could probably do this a little bit faster and a little bit better using other methods, but this method is easy to understand and easy to program. So first things first, this forward face is going to be if not isOpaque. We're going to want to pass it in the x, the y, and the z minus 1. Because we're not doing any z-axis stuff here. This, on the other hand, is z plus 1. See that? How we're adding vector3.forward? That's z. So here we're going to go ahead and say if isOpaque. This one is the forward. This is the right and left faces. So this one is to the right because we're adding in the right value there. And this one is to the left because we're not. And then we're going to comment these guys out just for a minute so that we can see whether or not we're on the right track. All right. Oh, no. If index is less than 0 or index is greater than or equal to map.length, debug.log index calc error x y z somehow came up with index. Return false. All right, so you can see that we came up with negative values for these indices, which is interesting because in theory that should return a false right away. See, if x is greater than 0, idiot. That's fine. It should still work. Yeah, you can see how the interior faces are now gone. That saves us a lot of memory. So now we'll just finish it off with the last set of faces, which are the y faces. So this is y minus 1, and this one is y plus 1. There we are. So now we have a fully functional voxel generation system. So obviously only creating blank white voxels at the moment. There's no UV mapping going on. That's actually pretty trivial to add, but there's no reason to add it yet, so we're not going to. What we are going to want to do is make it a lot easier for us to actually put these voxels together. So in about half an hour, you can create a voxel system, but it's going to take another half hour before we can actually edit the voxels properly. So one thing we're going to need to do in order to have this work is we're going to need to have a mesh collider set up, because the mesh collider will actually let us click on the box properly. So for that, we're going to go ahead and add in this mesh collider. We're going to need to add in the mesh collider element here as well. And then once we've calculated out the mesh, we're going to want to set the mesh collider mesh equal to that as well. And I don't know whether we have to tell it to recalculate. I think it understands it right away. Let's go ahead and give it a shot. Hit play. What we're going to do here is put in some values. and then tell it to calculate out the mesh. There we have an awkward mesh here. And I forgot to assign it. As I always say, you have to plug shit in before it works. If you forget to plug shit in, it's not gonna work. That's 22, not 2. There we are. So you can see that we've got a rather chaotic mesh happening here. And if we take a look at the mesh collider for this mesh, I can't tell whether it's working or not. It definitely has the mesh, and I think that if we turn off the mesh renderer, will we be able to see the mesh collider here? Yeah, there we are. So there's our mesh collider, and as you can see, it's come up with a mesh collider that is almost exactly the same. In fact, it might be exactly the same as the mesh we passed to it. This is something that works fine as long as you're only doing raycasts, I think. This kind of mesh collider is not convex. It has a lot of little indents and stuff, and it doesn't, gaps and stuff. So it's not going to work very well as a physics system, but we need to be able to click on this stuff, which is why we're doing it this way. What we're going to do is we're also going to, when we start up, set the map 0 equal to 2, and then calculate the mesh. That way we'll have a mesh when we start. Because otherwise we won't really know what to do. We're going to go ahead and import the default assets for characters, just so that we can get ourselves a first-person view going on. This is the 5.5 set. I haven't upgraded to 5.6 yet, so it might be a little bit different. While it's importing, let's just check our notifications. Yeah. I'll just tweet one more time here. I created the Voxel mesh system. Now I'm creating the Voxel editing UI. And then we will pass it my location. El Boechi says, "Hi Craig. Hello, today I'm not working on the galactic line. I am instead working on a prototype that hit me too hard, and I can't ignore it. I wouldn't be able to focus on the galactic line, so might as well work on the prototype. As I mentioned before, we have a long weekend coming up, so I'll have a lot of time to put into this prototype if it is as good as it seems to be." Excuse me, a little bit of a burp. Straight into the mic. I'm sure that was very, very good. All right, so now we've got our first-person character. What we need to do is begin our raycasting stuff. Before we start that, let's make sure we know where we're pointing. The easiest way to do that is to create a canvas and then put a little something in the middle. Let's say an image. And if we put the image in the middle and we make it like 4 pixels by 4 pixels, we now have a point. See that? In the middle of our screen. Since we are editing something that is white, at least at the moment, I'm going to make that sprite black, but anything will work. Now what we need to do is create a raycasting system. So we're going to go back into scripts. We've only got one script did all that stuff, but now we're going to also have a player voxel editor script. And that's probably not a great thing to call it because editor is often used to mean something that is over here in the inspector, but it'll work. We're not going to be too picky. And we'll put that onto, it doesn't really matter what we put it onto, but the FPS controller seems like a good place. So here, we're going to make this, hello? Click to add or remove voxels. So here in the update, what we're going to want to do is determine a ray from the main camera. Ray equals camera.main.ray. And the screen point to ray is actually going to be better as a viewpoint to ray. Sure, we've got a viewpoint to ray, right? Yeah, viewport point to ray. Oh, I see. There's a port and a point. So we're going to want to pass it in a viewport point, and I think that it's going to be vector3.1 divided by 2, but I can't actually remember. We'll know for sure pretty soon. And we're going to have a raycast hit, and then we're going to do a physics. If physics.raycast ray comma out hit, then we know we hit something. So we're going to go ahead and just do a debug log, debug.log hit, and then hit dot name transform dot name plus at plus, and then hit dot point. Let's see whether or not this works. Hit chunk. So you can see that we're also hitting the ground. That's because it's all in the same setup. There's no reason to worry about that. And this will allow us to edit our meshes. So what we're going to do is we're going to make a left click add in a voxel and a right click remove a voxel. So the issue here is that we don't have any sort of cursor yet. Later on we'll be adding in cursor stuff, but for now we're not going to. What we are going to want to do is grab the voxel chunk that we're editing. So voxel chunk vc equals hit.transform.getComponent voxel chunk. And then we can just say what we're doing. So we'll go ahead and put in an edit voxel chunk and hit. So public void edit voxel chunk target and raycast hit. If VC, then do this. Else debug.log hit non-voxel chunk of hit.transform.name. That's fine. If input.mouse get mouse button down, we're going to want to add in a new value on a left click. Add voxel on left click. So that's going to allow us to just edit the map. But in order to do that, we have to know our X, Y, and Z coordinates. That's not too bad, because what we can do is we can simply convert them into local space for the chunk. So what we'll do is we'll say vector3 local coords, and we'll just say target.transform.world to local matrix is not exactly what I want. It's a convert point, something like that. Inverse transform. Hit dot position, hit dot point. And then we're going to just debug log that for now, just to see if it's right. So if we do that, that should say the same thing, because what we've got is a coordinate system which is collapse, please. Yeah, yeah, that's correct. So that should be fine. The question is, when we move this voxel, will we still get the right result? Yeah, we do. Great, perfect. So that means that when we click on it, we get a coordinate that is that doesn't care about the actual world position, and that will also work for rotated objects. So, for example, if we rotate this and then move it, and then hit play and click on it, it's the same thing. So we're doing it great here. And if we wanted to scale it, you can see that it still works fine. So regardless of what we do to our voxels, we can have this work out as planned. And that's perfect for situations where we might want larger or smaller voxels. Rather than scaling the size of the mesh, we can keep our mesh calculations simple and simply scale the size of the object. That will allow us to have, you know, giant spaceships or really teeny tiny furniture or whatever, just by changing the scale values on those. And the physics system I'm building loves that shit, so it's fine. So now that we have the local coordinates, we need to tell the voxel engine to add something there. And the way we're going to do that is we're going to know that one of our elements is clean, but we're going to need the normal. So vector3 local normal equals target.transform.inverse transform direction. What's the difference between a vector and a direction in this case? Well, it's definitely supposed to be a direction, so plus at plus local normal. And now what we should see is that this has a perfect z normal. Yeah, perfect. We'll always have a nice crisp normal with this kind of setup. So that should make it real easy for us to figure out where we want to be. So what we're going to do is int x, and that's not how you spell int, equals local mathf.floor to int local chords dot x, and then we're going to do int y and int z. And that'll tell us our map coordinate positions. What we're going to need to do over here in Voxel chunk is actually create a map coordinate translator. So public int chord to index. Int x, int y, int z. And we will just go ahead and plug this in. And then here we can just say chord to index x, y, z. This is going to be valuable because we can overload it with a vector. Public int vector3 chord. And then what we'll do is we'll just say return chord to index mathf.floor to int chord.x and then y and then z. Boom, perfect. And that way we won't have to do this. We can just say, well, no, we still have to do that, unfortunately, because we are going to need to add numbers. Well, no, we're not. That's fine then. No, we are going to have to do it. Sorry. So int index equals target dot index chord to index x, y, z. So what we're going to want to do is this isn't actually what we need. Oh, what am I talking about? Of course, local chords plus equals local normal, and then we can say int index equals target dot chords to index local chords. And then what we can do is test and see whether the index is valid. So if index is greater than 0 and index is less than what's it called, target.map.length, then we say map target.mapIndex equals 2 target.calculate mesh. Perfect. So that should work except for one little value, and that is that we aren't actually checking this. So what we're going to do is we're going to check this as well. So here we're going to go ahead and say return -1. So if the chords are just not valid, then don't give you an invalid coordinate. Don't give you an invalid index. That'll keep us from accidentally looping off one side and coming back on the other. Also, we want to make sure that this is local chord rather than in, you know, just a general world coordinate. All right, so that should work. Let's go ahead and try it out. Elbow says, Craig, were your stream in the past 1080 in the past? I thought they were 1080, but they're 720. You know what? Oh, God damn it. I am streaming in the wrong profile. I'm sorry. You're right. I am actually not in my streaming profile. I'm in my recording profile. Am I actually off screen? No, the screen is the right size because I adjusted it for the recording. You're right, Elboechi, but I can't fix it without rebooting. Rebooting the stream. And I don't really want to reboot the stream. Are you having any other problems seeing the stream or hearing the stream? If it's just that it's low res, sorry, it won't be low res next time. I'll remember to fix it. Ah, perfect, perfect. I say perfect when I don't mean that at all, because you can see that it's actually bouncing twice rather than just once. The question is, yeah, it does appear to be skipping a coordinate, and you can see that that only skips in the increasing direction and not in the decreasing direction. So that means that we've got a little bit of nonsense happening. Yeah, well, actually, I haven't even zoomed in on the code, so I'm sure you were having a hard time seeing the code if you were actually looking at the code. I forget that people actually look at the code sometimes. I think that a lot of people just have I think that the two people that watch just have me on in the background for my continuous patter. All right, so the normal is always going to be 1 width. It's always going to be correct. But the problem is that the local chords are not rating it properly because they are at the edge of the next coordinate set. So what we need to do is actually transform the hit dot point by the hit dot normal divided by 2. And that ought to get us the right values. Let's give it a shot. Maybe that's too much. Maybe it needs to be like a quarter. You can see that increasing is now correct. How about decreasing? Oh, it's also correct. All right, so that did work. Okay, so this looks like it's working. So it was an hour to put this together. From scratch, we now have a fully functional system with collisions and the ability to click to add voxels. So this is pretty good progress, right? It's only 8 high at max, so that's why it's stopped going up at that point. We don't have any sort of chunk creation system for automatically failing over to the next chunk or anything, but that should work. Now that we can do all of that stuff, we're going to take the map off of the editor. Hide in inspector, just because it's going to get really, really gnarly if you ever accidentally open it up and it's got like 10,000 entries. So with that in mind, we can increase the chunk size from 8 to 16, and it should work out. Fabsa says, hell no, I'm studying the code. Sounds good to me. It's always nice to have someone that likes what you're doing enough to actually look at the code. This is very, very basic code, though. Anyone who's built a system for creating voxels is the same. It's going to be the same. Just remember to cull the inside of your faces. Right now, there are several things I'm not doing. For example, I'm not actually checking to see whether or not we are over the maximum number of verts. Unity has a strict vert limit, and we can theoretically hit that. But I'm not going to worry about that for a prototype. We'll deal with that later. Yay! All right, so what we're going to do next is add a second sun into the sky. And no, I'm being serious. It's too dark to see what I'm doing, so we're going to go ahead and put in more sunlight. There we go. Make it blue and not nearly as bright. There we are. And let's see. Elboichi says that it's right to have me in the background. I am right that it's soothing to have me in the background. Fabsa says, Erdroy says, voxels? What? Yeah, I got a really, really good idea for a voxel system using the physics engine that you might have seen if you'd seen my channel in the past 24 hours. So I'm just creating a quick little voxel engine to do a prototype. It's a long weekend, so it's a good time for me to do some... it will be a long weekend soon, so it's a good time for me to do some prototyping. I haven't given up on the galactic line, but this is really a compelling idea, and I really would like it if it turned out good. Fabsa says the game I'm working on does not include voxels, but he's always found them interesting. So what we're going to do now is implement the right click to delete, which is trivial. It's trivial, but we have to do it. So here is the add, and now we're going to do the delete. We don't need the normal for the delete, so this will work fine. Boom. Now we should be able to add and delete. Yep, see? Perfect. Hurrah! So what next? Well, there's still a lot of stuff we have to do, but I think it's time for us to start to build the physics system, because that's the point of this. So what we're going to do is begin to understand the physics that we want out of this game. The only problem is that the way I've got it set up right now, there's only one kind of voxel. Because there's only one kind of voxel, the physics system is going to be chunking things up really aggressively. So I think we're going to need to make it so that there's multiple kinds of voxels. Not a big deal. We'll go ahead and do that right now. The big thing that we're going to need for that is a panel in the upper left-hand corner of the screen. Like that. With a text box inside of it that says what we are currently using. Oh, not a particle system. Particle systems and text boxes are not interchangeable. So we'll go ahead and set this up as a darker black with a bolded format. We'll go ahead and say it is material and then 2. So now what we're going to do is have a global material system here in the player voxel editor. Global, in this case, does not actually mean global. It's local to the player. Public byte material loaded equals 2. And then we're going to have a system where we're going to have an event, a string event. So events. Public class string event is descended from a Unity event of type string, yunk, and then we're going to go ahead and say that this is system.serializable. And once we have that, we can just punch this in as a new string event, material changed. We can also have that be a byte event later on, but for now a string event is fine because it will allow us to do some stuff. What we're going to want to do is have in this part up here, outside of the edit, we're going to want to check and see whether or not we've seen a mouse scroll wheel. Int scroll wheel equals input.getAxis mouse scroll wheel. If scroll wheel is less than 0, then we'll want to material loaded minus minus. If material loaded is less than 2, material loaded equals 2. And we'll also want to material change.invoke. Material loaded. There we are. Same thing with material going up. So if the scroll wheel is greater than 0, thing is, I think this is actually backwards, but that's fine. If material loaded is greater than 10, then material equals 10. There we go. That should allow us to load up any material. And down here, we can tell it to load up our material rather than 2. Now, obviously, at the moment, that's not going to end up doing anything because we don't have any of those other values. So what we need to do is have this be the opposite of the way it is now. So this would be case 0, case 1, default. And in addition, we're going to want to have it so that when we're creating a voxel, we understand what sort. See how this is in case 2? This is also going to be default. And there's going to not be any unknown materials. So we're going to say to create a voxel of the map.index type, which is down here. And the problem is, where's our coord index is opaque create voxel? Here it is. So the problem is that we create the faces, but we don't end up creating the UV map that we need in order to do it properly. So what we're going to do right now is just grab these and shunt them off into their own area. Region supporting functions, utility functions. Being zoomed in makes it a little bit harder to figure this stuff out, but that's fine. We're going to have some vector2 UVs. And what we're going to need to do here is when we create the face, we're also going to have to create the UVs for it. The downside of that is that we're not passing the material in, and so we're going to have to. So let's go ahead and add in byte material here. It's kind of unfortunate that we have to keep passing this around. We could make it something which is outside of the function, but that would risk having it intrude when we don't need it to in a weird way. So we're not going to do that. We're not going to let it have some weird cached system going on. Erdroy says, what are you using 0 as 1? Is it the air? 0 is the air and 1 is an object. We'll have an object system for things that aren't voxels but are in voxel space. We need to know that those voxel areas are taken, but they don't count as voxels. Ibuichi says, what are those regions actually doing? They're not doing anything. The regions are just for readability's sake. Erdroy says, maybe you should make the blocks solid color instead of textured. Erdroy, that is an excellent idea with only one problem. There is currently no default shader, as far as I know, that does materials. But I think that's actually better than the UV system. So we'll go ahead and do that. Colors. Right. So we'll go ahead and do that, and then we will put in a shader that can handle the colors. So here we can see create voxel face material. We're just going to need to add in the colors that we would need. So color 32, color equals color of material. And then we're going to say colors dot add color. There. We do not yet have a color of material. Let's add it in. Public color 32, color of material, byte material. Switch material. Default, return color 32.white. No, I can't do that. Okay, so we'll just say return new color 32. And we'll just send it in as a 255, 255, 255, 255. Erdroy says it is easy to do. It's easy to do. I've done it before, but I don't have any materials currently loaded up. So I'll have to... No shaders currently loaded up, so I'll have to think about that just a little bit here. Let's go ahead and make this something heavy, like 125, 125, 125. And then after that, we'll just choose some random colors. It doesn't really matter, but we've got 10 of them. 3, 4, 5, 6, 7, 8, 9, and 10. By which I mean we have 8 of them, but we have, or 9, I suppose. So we'll just go ahead and fill these in with random variants, 255 and 0, 255 and 0, and 255 and 0, and 0, 255, 255, and 0, 255, 255. And then, of course, up here, we're going to need to add in the colors into the mesh. So mesh.colors 32 equals colors.toArray. Now we should be able to hit play and everything should work, but we broke something. Oh, int scroll wheel, float scroll wheel, sorry. The scroll wheel always is an integer, so I forgot that it wasn't listed as one internally. So in theory, these should have colors assigned, but obviously we have no way to check that because we do not have a material that is currently using it. So let's go ahead and try and create a material that is color aware. Material, colorized material. I'll drop that on. Now, I don't know whether or not there is a shader in default Unity that does colored. No, that's like. Okay, so there isn't. Is there another pack that I can import here? No, I don't think there is. It means I have to create one. Oh, that's a pain in the ass. Oh, there's the asset store. So what we're gonna do is I'm just gonna load up the material I need from. Sorry, I'm gonna load up the Shader Forge asset pack. Hello, I'm trying to tell. For fuck's sake, did I not get logged in? Let's go ahead and log in where nobody can see me. Oh, thanks, Unity. Very helpful. There we go. I don't know why the store doesn't just show me what I've got downloaded and ready to work with here. There's Shader Forge, import. Yeah, just grab it all. That's going to be a minute. Erdroy says that standard shader, we can get shader colors to work by making a new shader.add vertex pragma line in the C program block. Yeah. So I could edit their shader, or I could put together a shader that is essentially their shader anyway, but edited. I'm not actually sure which is easier, but I've done it this way a lot, and I haven't done it the other way at all. So I'm presuming that this will be a little easier. So what we're going to do is we're going to open up a new Shader Forge window, and we're just going to quickly create a PBR shader. We'll call it Colorized Shader. And this is the standard, right? So let's go ahead and add in a vertex color, and we will have that join in on the fun. Boom. Easy as pie. Compile shader, please. So now that that's done, we should be able to switch this over to being the new shader. Shader Forge Colorized Shader. We can hit play. It's black. I didn't expect it to be black. I actually don't know whether that's because the colors are black or... Well, let's go ahead and make it so that switching materials actually shows up properly. The FPS controller has a new event, this material color changed. We can drop in this text panel and tell it to change the text. And that should allow us to be able to see whether or not we're actually changing materials. And you can see that we are. So this material shouldn't be black. None of the materials should be black. I don't know whether they are being registered as black or not. For now, what I'll do is I'll add in a color checker. So debug.log. God damn it. Colors 0. Let's just see what it has to say for itself. It says gray, so this is clearly not properly rendering. That's odd. Why is it not properly rendering? It seems like it's fine here, doesn't it? I mean, technically speaking, we don't need the texture or anything like that because we're not using any UV maps. Why would this be rendering as black? Is it because we don't have a texture? No, because it would be rendering as black here if that was the case. This chunk is clearly rendering as the right color. So why does it... That can't be it. Maybe I should do it the way of just editing the Unity thing. I've never seen this before. Why is it black? If I was to drop the ground material on it, what would happen? Mesh renderer, materials, ground. It turns gray. If I were to go into the Shader Forge window here and load up, no, not a script, and take that out, just delete it, boom. Then we compile the shader again, and then hit play. It's black. There's something wrong with the Shader Forge material at a fundamental level. That's new! Alright, so I guess I'm going to go ahead and try Erdroy's approach. You can get shader colors to work with the standard shader by making a new shader and then adding in some values. So let's go ahead and do that. Shader. Standard surface shader. There we are. Colorized shader 2. We'll delete the original one here. Bang. You're gone. You're out of here. This should turn purple, right? Yeah. So let's go ahead and open this up, and let's read into their values here. Making a new shader. Add vertex vert to the pragma line in the CG program block. Here it is. So we got pragma, surface, surf, standard, vertex, vert. Okay, I can do that. Why can't I paste? Whatever, I'll type it in. Is that all I need to do? You can then add more crap. Oh, for fuck's sake. Close this down and reopen a less broken version, so that I can cut and paste. This isn't even vaguely straightforward. Why is there a struct v2f? I have to put a new struct in, really? Oh. Yeah, that's easy, right? Just cut and paste 400 lines of code. This doesn't have the... Okay, it does. Okay. Let's see whether this works. Shader is going to be custom colorized shader 2. All right, let's see this. Colors are not loaded properly. There is no data, so it's black. I think you're right, because this is clearly supposed to have some colors or something. But I'm not getting any warnings that the colors aren't loaded correctly. Should I put in some checks? If verts.count does not equal colors.count, debug.log, weird, wrong number of colors. Another option is that this might not actually be accepting those values. We may have to do it like set colors. I bet we have to do it set colors, which takes a list. That's right, I remember this bullshit. The idea that we have to pass it a list of colors because for some reason Unity doesn't want to use arrays, which are better in every measurable way. But you can see that there's actually sets on all of these, and they all take lists. Huh. This one takes an integer set and a list. That's not too bad. And that also includes a bool for recalculating the bounds. Oh, that's actually pretty good. Let's go ahead and use that. Can this take a list or only... Yeah, brilliant. It can only take a list. That makes no damn sense. I bet it's different in 5.6, and this is just the nonsense that comes with using a slightly older version. Set vertices. Really? Just a list? Whatever floats your boat, I guess. Still nothing happening here. Let me go ahead and create the colorized shader again using the Shader Forge window. Now this is also black though, so I think that it's still not working somehow. Erdroy says that I didn't program the shader wrong when I cut. I did program the shader wrong. I'm missing albedo equals in.vertex color times something. Presumably this. Let's go ahead and try that out. It'll be a race to see whether or not I can finish the one that's using the Unity shader or whether I can finish the other one first. Ah, this one works. Okay. So I don't know what's up with Shader Forge. It used to work fine, but now it's all busted up. So you can see that now we have a bunch of Polytechnic colors for our system. And we can have these have different physical attributes and cluster in different ways with our physics system. So what we're going to do is we're going to build the physics sub-object elements first. So that involves creating a physics sub-object. And we're going to go ahead and open that right up. So these physics subobjects are a cluster of voxels and or an object. So we're going to go ahead and start with the idea that they are just a cluster of voxels. The reason that they're going to be a mono behavior rather than being just a data element is so that I can visualize them using widgets. That's going to be a good thing for us to do. However, in order for them to work properly, we're going to need to have them have bounds. There are a lot of possibilities in terms of defining these bounds. One option is I can simply list all of the x, y, z coordinates that are being affected. Another option is I can simply create a literal bounding box and just say that every voxel of a certain color within this bounding box is part of the subobject. That has a lot of benefits to it, and that's the way I thought through beforehand, thinking how it works. So I think that's probably for the best. Affected material, and then we're going to have a public. We could use vector 3s. I guess that's probably for the best. Min corner, max corner. Now these physics subobjects are going to need to be displayed. So we'll go ahead and say on draw gizmos. And we will draw them. So color 32 color equals voxel chunk dot get color. Okay, so that's not static. Let's go ahead and just make it static. Get color of material and then pass it in the affected material. And then we'll say gizmos dot color equals all that. And then we'll say gizmos dot draw wire cube, and then we'll give it the center, so min corner plus max corner divided by 2, and the size, which is going to be max corner minus min corner. There we go. You can subtract 2 vectors, yeah. Perfect. So this should draw fine. Let's go ahead and create a test version. We're going to go ahead and call this physics subobject. Drop the subobject in here, and then give it some values just for the sake of having some. So our max corner and our mis, there we are. That's going to be what it looks like. And you can see that that just draws a little box around it. And that should be good enough for our purposes. What we do need to do, however, is make it so that these get instantiated properly by the voxel object system. We could put that into the voxel chunk system, but that's a lot of extra math and functionality for that one very, very focused class to have. So we're going to create a new class, which is going to be called the physics object, like so. This physics object, which we'll put at 0, 0, 0, will contain the chunk. There we go. And that way we can have our physics object here, open it up. And we're going to want to have a public physics subobject, what do you call it? Subobject prefab. We're also going to want a public transform subobject container. And then we'll go ahead and create that. Later on, we'll translate this over into more generic data sets instead of putting them in the game world. But for now, debugging purposes state that we are going to do it the inefficient way for the sake of having it visible to us. So our physics subobject is going to need to have a couple of things go on. First things first, it has to know when to calculate its physics. And to do that, we're going to go over here into the voxel chunk, and we're going to create a new event. Public unity event on recalculated. And then down here in calculate mesh on recalculated.invoke. Over here in the physics object, the very first thing we're going to do, public void awake. We're going to find all of the voxel chunks that we contain. Voxel chunks, protected voxel chunks. We'll say chunks equals get components in children voxel chunk. True. And then we're going to go through all of those chunks. And we're going to go ahead and sign up for them. So chunks dot on or dot recalculated dot, what is it called? Chunks A dot on recalculated dot add listener recalculate. Public void recalculate. We'll also make this a menu item. In this, what we're going to do is we're going to do a for each voxel chunk in chunks recalculate chunk. Public void recalculate voxel chunk. All right, so now we're ready to get down to it. We're going to be creating a physics chunking system for our voxels. And the way we're going to be doing that is we're going to be going through all of our voxels and quickly determining whether A, they're already in a physics chunk, or B, they need to be added to a physics chunk. To do that, we're going to need to have a bit array. So we'll go ahead and, I guess a bit array is its own standing value thing. So we'll go ahead and just call it in physics object equals new bit array, and we can give it the length of chunk dot width times chunk dot map dot length. There we are. So every voxel needs to be in a physics object, subobject. So what we're going to do is we are going to simply walk through our map and tag every single chunk that is within a given cube. At the moment, and is contiguous. And at the moment, that might be pretty simplistic. We may have to change that later. But this isn't going to be too hard. We're just going to start at 0 and move on. So for int a equals 0, a is less than chunk.map.length. Well, I guess it's probably better if we do a for int z equals 0, z is less than chunk.depth, z++, for int y equals 0, y is less than chunk.height, y++, for int x equals 0, x is less than chunk.width, x++. All right. Int index equals 0, index++. Let's go ahead and add in all of these brackets because we might need some. So what we're going to say here is if in physics object index, then continue. Are we already in a physics object? Skip us. Otherwise, what we're going to want to do is create a physics object based on where we are, and then spread in every positive direction to find all of the bounds that we can handle for that physics object. Now that is a little convoluted because we will be able to work backwards as well, so this is a situation where we're going to want to keep up to date keeping this in physics object array working. We could do it using a recursive system. I'm a little bit worried about reaching recursion depth if we do it with a recursive system. So what we're going to do instead is we're going to use a list of coordinates, and that will be our setup for doing this. So we're going to have a list of coordinates which we're going to be checking. So we're going to go ahead and say coordinates.add and then new vector3 xyz. Then we're going to just go ahead and say while coordinates.count is greater than 0. We're going to go ahead and coordinates.remove at 0. Oh, that was weird. Vector3 coord equals coordinates at 0. Remove at 0. And now what we're going to do is we're going to check all 4 orthogonal directions, and if it turns out that there is a value there, we are going to go ahead and add to it. So what we're going to do is we're going to add in the 4 orthogonal directions from where we are, but only if our coordinate is the current value. So what we're going to need to do is keep track of the physics value in play. Byte material in play equals 0. And then here what we're going to do is we're going to say in physics objects continue if chunk.map index is less than 2, then continue. And lastly, we're going to say material in play equals chunk.map.index. There we are. That should allow us to keep track of the materials in play. And then here we're going to say if chunk.map and then the index of our position. So chunk.map chunk.coord to index coord equals material in play. Then we're going to add that to the objects we need to work on. So in physics object index equals true. And then we're going to go ahead and add the 4 other values that we need to this physics object. So that would be, sorry, 6. So that would be coordinates. No, yeah, coordinates.add new vector3 coord plus vector3.left, vector3.right, vector3.up, vector3.down, vector3.forward, and vector3.back. We're also going to want to say that if our index is not valid, we're going to want to kill it. So int index equals that. And then we're going to say if index is greater than 0, then do this. I think we're already using index. Sorry, I can't use the same thing twice. That would be dumb. So we're going to go ahead and change that from the word index to current index. This could be in its own function. That would be a little bit better, but then I'd have to make certain things non-local variables. I don't feel like doing that. Okay, so let's go ahead and clean up this index stuff. There we are. So that should work. What we're doing is we are going through all of the coordinates that we specify, and we're adding to the list if there are more coordinates. But what we're not doing is actually creating a physics subobject and setting it up properly. So let's go ahead and do that now. Physics I guess we're going to want to do it. Physics subobject PS equals physics subobject dot instantiate prefab subobject prefab, and then put it inside of our target subobject container. And there we are. We're going to want to set up the material. And now we're going to want to have the ability to add a point. So let's go ahead and put that in. Public void include point and vector3 point. We're going to go ahead and just stretch it so that that fits. So if min corner is less, well, let's go ahead and just quickly check and see whether or not this is valid. Public bool initialized equals false. Now the reason we're checking if it's initialized is because otherwise 0, 0, 0 will always be our minimum point, and we don't want that to happen. So if we're not initialized, then we're going to want to say that min corner equals point, max corner equals point, initialized equals true, and return. Otherwise, if min corner dot x is greater than point dot x, I think there's a better way to do this, but I can't remember it off the top of my head. Point dot x equals min corner dot x. Is there like a vector3 dot min? Returns a vector that is made from the smallest components of two vectors. Yeah, there is. Okay. So we're just going to go ahead and say that min corner equals vector3 dot min, min corner and point. And max corner equals vector3 dot max, max corner and point. There we go. Perfect, right? So with that in mind, over here in the physics object, we can just tell it to add the point. So ps dot includes point, and then we'll pass it in the coord. Right? So what we have now is a setup where we should be getting all of these values and creating all of the things we need. The last thing we need to do is when we recalculate stuff, we actually need to clear out all of the children in our subobject container. So for each transform t in subobject container, destroy t.gameObject. Otherwise, we'll end up with multiple chunks, and it'll just be dumb. All right, so let's go ahead and see what happens here. I didn't hook it in yet, but it seems to play. Let's hook it in. The reason, I actually don't think I need to hook it in. Yeah, good, it's already hooked in. Let's go ahead and give this a shot. If we take a look, we've already got a subobject in our subobject container. It says that it's not initialized, which is odd. Initialized equals true right here. Which kind of implies that it's not getting initialized properly. Let's go ahead and set these all to 0 so that we can see it when it's not initialized properly. Go over to the console and hit play. It says our RGBA values, but it doesn't tell us what's going on here. So we're creating the physics object, but then we're not instantiating it. We're not doing anything with it. We're just kind of, we're putting it into the game world and then just leaving it. So what is going on? Well, we're in here. We have now determined that the object, or the map position we're on, is not in a current physics object. So what we're trying to do is create a physics object, which we set up properly. We also set it up right here with the material in play being the chunk map global index. So what's going on? This isn't happening. Debug.log. Chunk being created with material and then material in play. Let's just see what's going on. Chunk being created with material 2. But if we take a look at this, oh, it is material 2. All right. So that means that it's getting the material correct. So we must have a problem down here in the coordinates. So this should be running. Let's just go ahead and put in some debug. Debug.log. Boonk. Give us a whole bunch of exclamation points. 1. Well, 1 is correct. Let's go ahead and give it 2. 2. 8. 8. Okay, so we are running. Let's take a look here. So current index equals chunk.chord to index chord. If current index is greater than or equal to 0, there's our problem. So now, if we take a look at our physics object, it's initialized. It's only 0, 0, 0 because that is the only point contained. If we expand this, ooh, we get a nice crash. I was wondering how long it was going to take to get one of these. We clearly have an infinite loop, so let's go ahead and kill it off. I'm not sure how much we might have lost there. I don't think very much. Voxel physics prototype. All right, so we're back in the game here. When was the last time we saved our garden? We don't have any of the stuff set up. Okay, that's fine. We can set it up. So let's go ahead and create an empty object for our physics object. Create an empty object for our containers. That's not how you spell container. That's also not how you spell container. Container. There we are. Container has to contain the word contain. And now let's go down to scripts, put in our physics object, drop in our physics container, go up here to assets, drop in our physics subobject, drop our chunk into our physics object. There we go. Now we had an infinite loop last time we tried this, which means that there's chances are high that there's something going on in here which is creating an infinite loop. So what happens is the coordinate at 0, is 0, 0, 0, and the coordinate at 1, 1, 0, 0, are bouncing back and forth. And the way that that works is that they're not getting properly added into the physics object, or we're not properly checking whether the physics object has been set. And that's definitely the case. So here what we have to do is, if the physics object has been set, we need to stop. If in physics object current index, continue. Perfect. And that should keep us from having our infinite loop. That's the point of that. I just forgot the line. Oh, if in physics object current index. One of those sets of parentheses should work. All right. So now, argument out of range. I didn't expect that. Hello? Okay, close this down. Relink with the current set. Okay, so for some reason it's not letting me pop it up. That's never a great sign. So basically, what we have here is the current index has to be in here. There we are. Because we weren't actually checking to make sure it was valid. That should do. All right. Let's go ahead and click here, and then we can just adjust our material and click here and here and here and here. And then we can pause it, and we can take a look. So if we take a look at our chunk and we turn off the mesh renderer, these physics containers, okay, so this physics subobject is set up properly, but it's the only one in here, and it's not properly rendering because it's a 0 width object. So let's go ahead and fix the renderer a little bit, and that's what we're going to do is physics subobject rendering, vector3 true max, or visual max, equals max corner plus vector3.1. But why aren't we getting the second set of coordinates? We should have not just the bounding box for this, but also the bounding box for our second material. But as you can see, we've only got the bounding box for the one material here. You can actually see it bounding properly. See that? It's already there. But this material is not being included. So there are a couple of options. One option is we might not be proceeding. Maybe we're breaking out of this for some reason. Another option is that we might have been marking those as in the physics object already. Let's go ahead and put in some more values here. Some debug values. Debug.log skipping x plus y plus z plus it's already in a physics object. And we'll go ahead and see whether or not that is the problem. You know what? I think I can twist it around underneath. Yeah, let's go ahead and do that just for kicks. All right, you see that? You see that? Just then when I did that, it popped in the second one. So if you look over on the left, physics container has two physics subobjects right now. And if we hit pause, you can see that both of those physics subobjects are correct. We have the purple one bounded by the purple and the gray one bounded by the gray. But when I delete this one, it drops down to a single subobject. That means that it's not properly calculating out one of these x, y, z coordinates. It's only doing x or y or something similar. It's not doing all of them. Let's go ahead and put in a test just to check that a little bit more here. If we click here, click here. It says chunk being created with material 2, but it does not say that it ever had any collisions with anything that had already had a material. Yeah, so we're not getting any problems with this. It's all going to be a problem with it not actually executing the global index properly. The global index increases down here. Is there something that prevents that from actually working? Yes, there is. There's a lot. So we're going to go ahead and set the global index instead. It's a little bit slower, but I don't care. So we're going to go ahead and say chunk dot coord index xyz. And that should take care of that. So now that we have that set up, let's go ahead and try to get some physics objects. Aha, perfect. See it? We've already got our physics objects up and running. Okay, let's go ahead and add in another material. Let's do a broken material. All right, we're looking great. Look at this. We have 4 physics subobjects that are containing the bounding box of each material type. If we turn off the chunk renderer, you can, well, I got the chunk collider as well here. There we are. You can see that these are the boxes, the bounding boxes. And that is a great way for us to do it. There are very specific conditions where this doesn't work. But I'm not too concerned about them at the moment. Later on, I can try and figure out how to deal with them. But for now, it should be fine. What I'm going to do now is join these brownish blocks together, and we should see one of those physics subobjects disappear. Yes, perfect. All right, so now our physics system is literally half done. Yesterday, I spent 3 hours programming from scratch a physics system that worked from this position. So the physics system that I created yesterday could get plugged into here. I have to recreate it just so that it's a little bit more flexible for in purposes of damaging the voxels. But we are now ready to do some physics. And you can see why I wanted to put this together, because it's not going to really take long, but my voice is going. And it has been 2 hours. So what I'm going to do is I'm going to stop streaming. I'll probably put together the physics system off camera, but I may stream again some other time before Sunday, just at random, with more tests and stuff. Let me know what you think about that. Peter Nerlich says, could you maybe summarize what you're working on? I suspect that has to do with the video you just put up. You seemed quite interested about the idea to make that with voxels. That's exactly what it is, Peter. It is me putting together the physics system for voxels. And what I've just done is I finished creating a voxel editor and a voxel mesh display and the part of the physics system which clusters the voxels into physics sub-objects. So basically, if we take a look here, I've got these bounding boxes that you can see. And each of these bounding boxes is a physics sub-object, the equivalent of what you saw in the video as a tank or a landing leg. Not even a landing leg, those are 3 different objects, but you know, each one of the little objects on the graph. So what happens after that is these get their connections calculated, they get turned into a graph, and then physics can be deployed against them. That's a lot of fun for me. There are a lot of kinds of cool physics you can do with voxels that you couldn't really do with the spaceships, which is why I want to try this out. For those of you who haven't watched the video is how to do stress simulations in complex objects. And it has a fairly solid number of... it has a fairly solid example of how that would work with a spaceship. Now I'm doing it with a building and voxels. I'm excited for it because the kinds of damage that voxels can take is a lot more interesting than the kinds of damage that spaceships can take because they can crumple and they can do all sorts of fun stuff. Although I'll have to improve the display system so that you can tell how much damage a voxel has taken, because right now you can't tell. If that answers your question, Peter, or Mr. Nerlich, I don't know which you prefer, let me know. If not, also let me know. I'm not going to do any more work today because my throat is getting pretty sore, but I might do some off-camera work once I've let my brain rest a little bit. 2 hours straight of prototyping is about all I can take before I need a recharge. But what I can do is change the visuals very slightly to be a little bit more obvious. Physics sub-object, here it is. Now they should be just a little bit off of the target surface, which should allow us to see them a lot easier. And now you can see what I'm talking about with the bounding boxes. The gray one is the bounding box for our gray material, and the pink one is the bounding box for the pink material. So when physics is calculated on these, they will be on the graph, and we'll have some physics response events. It'll be nice. Well, Peter posted the video, so I presume that means that he understands what I said. Otherwise, I think that that's it for the day, video-wise. I can't do 24-hour streams or anything like that. I just don't have the stamina for it. So I now have more viewers than I have ever had over the course of my video so far. That is to say, I have 7. Welcome and goodbye. If you have any questions, ask it now. Otherwise, I'm going to sign off. I'll pay attention to the chat for 5 or 10 more minutes. But I'm pretty pleased with the progress. I mean, we did just create an entire voxel editor and voxel renderer solution in 1 hour and a half. So that's pretty fast. The rest of this will take just a little bit of thought because I have to figure out connectivity. I may have to do the connectivity calculations at the same time as I do the bounding box calculations, or I can simply assume that if the bounding boxes touch, they are connected. The problem is that's not always true. For example, if I were to do this, the bounding boxes technically touch, but I don't think you would ever want to claim that those two were connected. So I will have to do some calculations there. I'll think about the best way to do that. Peter says he's a college student, so I should call him Peter. What should I build as I sign off? How about a little hut made out of blue? Oh no, I can't get under because this default system is just the wrong height. That's fine. We can we can't crouch either. Can I get through? Oh no, I can't get through. Oh well. Let's go ahead and put together a hut like so. Oh, am I making the hut go the wrong way? I'm making the hut go the wrong way. So this would be the equivalent of a Minecraft hut that you build like in the first day. When you're like, oh yeah, let's go ahead and just put some dirt around in a hut formation. That's this. This is the dirt in a hut formation. Oh no, my head got stuck. That's fine. Now, if we take a look, this is all one chunk. And that's why I needed to break it up by material type, because in the physics simulation, what's going to happen is this entire hut will count as a single physics object. Now, I will be taking into account just the raw structural strength of the object against itself. So this physics object will weigh a certain amount, and it will also take us up a certain amount of space and all that stuff. And we'll just see whether or not the weight of it is too high for whatever this blue material is. And if the blue material isn't able to support the blue material's weight, then we'll be applying stress damage to it right away, even without anything on top of it. Of course, the real question is, what do you do to shore it up? And that might be something like, I can't fit through. That might be something like using pillars made out of a different material. Using pillars made out of a different material is not only going to be useful for making it stronger, it's also going to break up the physics system so that if we take a look at this now, we have several different bounding boxes. Oh no, we don't, because the roof is in the way. If we delete the roof, then you'll be able to see it. See, now we have several different bounding boxes. The doorway is one bounding box. The rest of the house is one bounding box. And each of these yellow pillars is its own bounding box. And that means that the mass won't be as critical. So rather than the entire hut being compressed down against its own strength, you're going to be able to have just the back of the hut and the door compressed down. And then these yellow beams are going to be something strong, and they'll be able to support the roof or whatever else you're trying to put on top. And it's going to be interesting to try and tell people that sort of information. Because clearly understanding how the physics of the system works is going to be a big part of it. And I have a feeling that a lot of players are going to try to just build their houses out of whatever is strongest, which will work, but it's like super expensive. And of course, it doesn't have all of the functionality you might want from your house. I'll have to think about the play of it a little bit. Right now, I just wanted to get the basics working. Yep, there we are. And Keelblock says, hi, any questions on where to begin with research on writing an okay, decent game manager in Unity? I don't know what you mean by game manager, but no, no matter what sort of version, no matter what that means, I'm afraid I don't have any suggestions because I'm not familiar with any sort of tutorials for that. But if I think of anything in the next 5 minutes, I'll be sure to let you know. And I'll see all you folks on Sunday, or if I stream before that, maybe I'll see you before that. Thanks for your time. Let's see. How do I stop the stream?